Okay, now done. Select a roller bearing for a lathe spindle operating at 120 RPM with an applied load of 18 kilonewton. The spindle diameter is 50 mm. And expected life of bearing is 10,000 hours. So now for roller bearings, you won't get a thrust load here. You have only a radial load. So first we calculate better you note on first given data. Speed n is 120 rpm. Radial load it is 18 kilonewton. Now spindle dia 50 mm. Life in hours that is what 10,000 hours. Now first we calculate so life of bearing in millions of revolutions. L equal to now it is a hour into 60 into 120 divided by 10 to 4 of 6. So I think this is 72 millions of revolutions. Next, we calculate the equivalent load. So now what is the relation for equivalent load? It's P equal to XVFR, okay, plus Y into FA into CSA. Now in this case, they have not specified the axial load. You can't go for comparison of the ratios FA divided by FR and FA divided by C naught. Okay. If you have the radial load and if you have a axial load, then you can go for ratios. Then you can compare with the value of E. Now in this case, as there is no axial load or thrust load, you directly calculate P equal to FR into CS. FR into CS. So now assume the service factor K is equal to 1. Now P equal to how much? It is 18 kilonewton into 1. It is 18 kilonewton. Sorry, 18,000 Newton here. 18,000 Newton. Now the life of bearing in millions of revolution based on load. Okay? That is what Ln is C by P, the power of 10 by 3. You can refer equation number 16.4b. Now let us substitute okay. Now what I'll assume, so Ln required has to be equal to Ln calculation. Now you find value of C here. Now you find value of C. So now C equal to P Ln now substitute value of P. So the dynamic load C equal to value of P. Now Ln you have calculated 72 millions of revolution. So now you calculate C. $64,934.
64,934.0.
Check it once again.
64,934.0. 934.
Right? Okay. Now corresponding to this dynamic load, you refer table which has a data for roller bearings. Okay. Now you just observe the calculated value of dynamic load. It is 634. Now the available dynamic load here, it is 69630. What they have specified? They have specified diameter has to be 50. Now the NU 22 series is not suitable. Okay, now this is what NU23 series. Now you have a dynamic load here 90960. That means the suggested roller bearing for this application is NU2310. Okay? NU2310. Right? Now you suggest the suitable bearing for this lathe spindle is NU2310. So is it clear? Roller bearing. So 2310 because we need to maintain diameter here. NU2309 it has a diameter of 45 mm, but the shaft diameter is how much they have given. So they have given shaft diameter as a 50 mm. The spindle diameter as a 50 mm. Is it right? Now we need to maintain the diameter also. So now based on the bearing size, you can't change shaft diameter. Sometimes it may failure, the shaft may failure sometimes. Okay, now we'll go for some 2-3 problems on worm gears on Wednesday class. On Wednesday class. And you just revise the syllabus. You just revise the syllabus. You check out what portion has been left. You just list it and send in WhatsApp group and send in WhatsApp group. So next class will be on Wednesday. We'll go for a design of worm gears. Is it okay? So you have any doubts? Shall I close this session? Okay, suggestion is you go through the syllabus, check out what topics have been left and list them and send to WhatsApp group.